implementation, you always or often have a coaxial cable leading to an antenna. And the only important parts that I want to highlight here is the attenuation per meter goes up as frequency goes up. The loss in a cable is higher if the cable is thin. It's also dependent on the technology used, but generally speaking, if it's thin, it has got a higher loss, and you can use it for smaller lengths or for lower frequencies. And then typically you find this curve. So if you find the losses are high and you want to go to lower losses, you can see these cables are much thicker. So cable loss is also typically related to the diameter of the coaxial cable, and the cost, of course, increases as you want lower losses. So I think those are the important aspects. Look at the distance. Is it relevant? In other words, if you've got half a meter, you can see that perhaps a 0.2, 0.4 dB loss is not relevant. But if you're going to use 10 meters, then that's becoming 4 dBs, and that's becoming 6 dBs. And then, of course, the frequency at which you wish to operate. So power handling, the thicker ones if you've got high power transmitters, but often not the case in cellular and Wi-Fi cases. Bend radius is important, and it is defined for each cable. Typically, the thinner ones you can bend sharper than the fatter ones, which is useful in an enclosure where you only need a small bit of cable. Price, and then an important one, connector availability. Not all cables can connect to all connectors.